Hello everyone. Today we'll be starting with yet another important chapter of class 12 computer science CBSE portion. It's called file handling in Python. Though here in this chapter I will brief you about what files are, but we'll be mostly dealing with text files, okay? I'll put up another video which will deal with binary files separately. Is that clear? So let's get started, okay? So let me just share my screen with you. Now, basically, what are we going to be learning in this chapter called file handling in Python? We are going to be learning what you mean by a file. What is a file actually? What are the types of files that we can see? How do you open and close files? What are the various modes in which you can open a file? How do you write something to a file? Here referring to text files. How do you read from text files? And the second part of my video will show you programs related to text files and solving some board paper questions there. Is that clear? So let's get started. Now, what exactly is a file? A file is nothing but a stream of bytes. But before I tell you what is a file, what is the importance of a file? Now, all this while when you were programming, you stored data in variables. So you said, let's say name is equal to input, enter your name. The user entered his name and that was stored into a variable called name. Let's say later on you said sal is equal to float in bracket input, enter your salary. So whatever salary the user entered, you stored it into a variable called sal, okay? Now, and you executed the program. The minute you close the program and you come back to the program, do you think you have the values of name and salary that was entered previously by the user? No, you have lost it. Why? Because these variables are created in primary memory. And primary memory, we know, is volatile. So the minute you close the program, it has lost the contents. So you can't keep using those values for further use. So tomorrow, if I wanted to know the same employee name and the same salary, there is no way I can get it because primary memory was erased. Then what do I do? Then the other option is that I should store these elements, whatever is the employee's name or his salary, probably into some permanent storages. Okay, permanent storages means on secondary storage devices like your hard disk or your pen drive. So when I talk about file, file is basically bytes of stream which is stored on secondary storage devices. So the contents of the file will actually remain there till you don't go and physically delete the file. So now what I could do is, after I read the name and the salary of the employee from the user, and I don't want to lose it, what do I do? From my Python program, I transfer it to a file. So what will file do? File will keep it safe till I actually don't go and delete the file. The contents of the file is safe and it is stored on secondary storage devices. Secondary storage devices are non-volatile, which means what? It's going to be there even tomorrow, day after, and after a month, unless and until you don't go and delete the file. Is that clear? So that's the importance of file. Some data can be stored permanently so that you can reuse it after some time. After 2 days, you want to view the contents or you want to add more contents. All that can be done if we had stored it on secondary storage devices. And a file is nothing but a byte of streams, or sorry, stream of bytes, which is stored on secondary storage devices. Okay, so file is nothing but a bunch of bytes that you store on secondary storage devices. And I told you, why do we store? Because our variables store them in primary memory, and primary memory is volatile. So no use of just storing it in variables and then keep writing it, keep you writing the same values over and over again whenever I want to run the program. Is that clear? Now, it's not just Python. In fact, every programming language offers some provisions where we can create and use files through our program. So now remember, when we basically, our program itself is a file. When you create a program called sample, your program is sample.py. Okay, so when we talk about files, we are talking about two files. One is our program file, and where one is the file where the data is going to be stored. But henceforth, whenever I say file, put it in the file, take it from the file, I don't mean my program file. I mean where the data file, where the data is going to be stored. Now, when you're talking about file handling, there are 3 steps that you need to know. Is how do you open the file? Then how do you process or do whatever with the contents of the file, either write, read, delete, modify, whatever, and how do you close the file? So these are the 3 steps that we generally perform when we do file handling. One is open, then process the file, and then remember to close the file. Now you might say, why open? Now, if I ask you to write like a letter or a document in Microsoft Word, won't you open a Word document first before you start typing? Your typing was your processing. So files have to be open before you actually can store data in it, or you can view data from it, or do deletion, or do modification, or do just searching. Processing can be anything, but the processing is only after the file is opened. And after you finish processing, it's a good habit to close the file, though when you close the program, the file automatically gets closed, but it's a good habit to close the file. And there are some benefits of closing the file that I will tell you when we go ahead. Is that clear? Okay, so now, what are the kinds of files? There are various kinds of files. Here we're only dealing with 2 kinds of files in our syllabus. That's text files and binary files. Now, what do I mean by a text file? A file that can be opened in any text editor. Now, are you aware that Notepad is a text editor? Yes. So if I can open a particular file in Notepad and I can view the contents or read the contents, then that means that particular file is a text file. It is readable. Okay. It is stored as text. Now, for example, now you've been probably opening your Python programs in a Python IDE, like I use Spider IDE. You may be using any IDE, but let me tell you one thing. You can even open your Python program, only open it and not execute it. You can even open your Python program in Notepad because your Python program is a text file. That means it stores data as text. So even if I open my Python program in Notepad, I will be able to view it. Will I be able to execute it? No, because Notepad doesn't allow me to run Python programs, right? For that, I need a Python, supporting IDE. Okay, then what's a binary file? Binary file, you have a lot of binary files in your computer. If you ever try opening a binary file, you will never be able to read the contents of the binary file because they store the contents in some machine form. Okay, so which means it's not text, it's not readable. Okay, it's readable for that particular program, but it's not readable. It is in machine form. So we as an outsider cannot see the contents of the file. But if you're going to open that binary file in the software that is meant for that binary file, then opening and showing you the contents will be of no problem to it. For example, let's say Word. Microsoft Word is a binary file. Now, suppose I try opening Microsoft Word in Notepad, it will show me weird contents which I will not be able to read. But the same document, if I open it in in Microsoft Word, it shows me the contents. Okay, so binary files are stored in a way that that you store the data in memory. Okay, so your image files or your Word documents, these are all examples of binary file. Now, the problem here is, okay, let's assume you opened a Spider IDE, Spider program or Python program in Notepad, okay? And you made some corrections. Now, when I open it in the Spider IDE also, I can see, oh, some correction was made. So it's easy to correct if there is an error. But when it comes to binary file, let's say you opened a binary file, let's say in Notepad, okay? And I told you would never be able to read, but you removed only one character from that file. That one character could be storing a very important detail of that file. And then if you try opening that file in its specified software, it just wouldn't work. Okay, so binary files are easy to get corrupted. But one important thing that we can add on with this difference is text files are readable. Okay, binary files are not readable. In fact, text files are portable. Binary files are not portable. Now, what do I mean by the term portable? Text files, whether I'm using an Windows operating system or a Mac operating system, any operating system, text files are going to look the same. But when it comes to binary files, the internal representation form for a Mac operating system may not match with Windows operating system. So the contents may not match. That's why we say binary files are not portable. It doesn't mean that I can't use a binary file from one Windows, let's say laptop, to another Windows desktop. No, there the operating system is the same. When I say portable, transferred between two operating systems, probably I have a binary file on Windows operating system and I'm trying to execute it on a Mac operating system. That may not be possible. Is that clear? So I hope you got the difference between text files and binary files. And the next screen just gives you an image form. You know, I have a program called circle.py in Python. But can you see where I've opened it? I've tried to open it in Notepad and it worked fine. It showed me exactly the way I had created it. Okay, look at the picture below. Okay, there's a picture called flower.png. So if I use any photo editing software or paint or anything, the picture would look like that. But if I ever tried to open flower.png in a notepad file or in a text editor, can you see on the right hand side, you can't make head or tail of what is happening there. But let me say I go and delete something, then the picture may not appear like this when it actually opens in a, you know, a picture imaging tool or a picture editing tool. Is that clear? That is what I mean by text files are readable. See, I could read a text file. I didn't open it in Spider, I opened it in Notepad, but I can read it because it's a text file. It's stored as pure text. But when it comes to binary files, I told you it's stored in the internal representation form. That what you see is all internal representation form, probably Greek and Latin to you and me, but that's how the file's structure is shown. But when you opened it in a software that allows you to open PNG files, it looked like a beautiful flower. I hope the difference between text file and binary file is clear. Now let's learn, before we start processing the file, the first step I said is to know how to open a file. So how do you open a file? We are going to be using a method or a function named as open, which helps me to open a file. And what is the syntax? You can see on the board, on the screen, you have file object is equal to open file name as the first parameter, comma, access mode as the second parameter. Okay, now what is this file object? File object is just some variable, okay, which is of type, it's called a file object because it is this object or this variable that will connect you to this particular file in your entire program after you have finished opening the file. I repeat, file object is very important because it is this variable or this object that connects you to this particular file in your entire program after you have opened the file. Now, here you specify the name of the file. So what I show you, let me just do some annotations here. So here you specify the name of the file, whatever file you're talking about. Okay. If your file is in the current directory, okay, that means you have a file in the current working directory, then you may just specify the name of the file as shown in the example below, that is sample.txt. So let's assume my current directory is C drive, users, my files. Okay, suppose this is my current directory. Then if I want to open the file which is belonging to this directory, I don't have to give that whole path. I can just give the file name. Okay, what happens if it's in some other directory or other location other than the current working directory? I will show it to you in the next slide. Okay, what do you mean by access mode? Access mode means what do you plan to do with this file? Do you plan to read the contents of the file? Do you plan to write something into the file? Do you plan to both read and write? Do you plan to add more contents to the file? All that is what the access mode is all about. So we have to specify that I'm opening this file and I plan to do what with that file. That is called its access mode. Okay, so now here I've written file in, f in. F in is the object that I will keep using, f in and f out, but there is no f out when I'm doing a write, I'm opening a file in write mode, and f in when I'm opening a file in read mode. Now, why do I call it f in and f out? There's no specific reason, but I call it as file input. Why? Because when I read the contents of the file, what am I doing? Transferring the contents from the file into my Python program. So for me, with respect to the Python program, it's an input. Okay, when I write something to a file, what am I doing? I'm transferring the contents from my Python program into the file. So from the Python, it's going out. Okay, so I call it file out. And not only that, couple of other programming languages don't call the modes as read mode and write mode. Instead, they call it as input mode and output mode. So input means read there and output means write. Is that clear? So just sticking to that. But like I said, file object names can be anything. Now I will use fin and fout is for me to know that whenever I've written fin, I mean that file is in read mode, and fout, I mean that file is in write mode, only to differentiate between whether the file is in read or write mode. If I just write X and Y, and I come to the 100th line of the program. Now I've forgotten what was X doing and what was Y's role. Was X in read mode or write mode, or was Y in read mode or write mode? So just to avoid that confusion, I would prefer to give fin for any file which is in read mode and fout for any file which is in write mode. Is that clear? Okay, so look at the example below. I have written fin is equal to open. So I'm going to make use of the function named as open, and I wrote the file name. Now you might wonder, access mode is not specified. Access mode is not specified is the reason being, by default, the access mode is the read mode. So if I plan to read the contents of a file, even if I don't specify the access mode, it's fine because it is by default the read mode. But if I have to make it the write mode, because if I wanted to write something to sample.txt, and I did not specify the access mode, then it would assume that opening sample.txt in read mode. Is that clear? So be very careful about when you should be specifying the access mode and when you can avoid. If it's read mode, by default it's read, you may or may not specify. But if it's write mode or any other mode that you will see soon, you will have to specify the access mode. Is that clear? Okay, so let me just take you to my next screen. Okay, but before I take you to my next screen, let me just clear up my annotations. Okay, now what did I specify here? Like I told you, if sample.txt was not on my current directory, current working directory, then what do? I give the complete path name. So can you see here, I wrote C:2 my files, 2 sample.txt. Now, what does this line mean? That the file name is sample.txt, but it's in a folder. Directory means a folder. It's in a folder named as my files, which is on my C drive. Now, the question that many people ask is, okay, why normally when we specify the complete path name, we only have a single slash. Why do we have 2 slashes here? The reason being, suppose you had any escape sequences. We know in Python we have escape sequences such as /n, /t. So these are all the escape sequences, you know, that we already have with Python. So suppose instead of just for an example, suppose instead of sample, your file name was tample. Okay, so won't it be /tample? But /t has a role in Python which says leave a tab space. So what do my 2 slashes do? We've learned in class 11. When you put 2 slashes, it means don't take slash as an escape sequence, take slash as just a slash. So when I say /tample, I mean a file named as tample, and I don't mean /t followed by a file named as ample. Is that clear? Okay, but suppose you want to give only single slash signs, then like I showed in the lower example, you could prefix the file name with R. So now if you see, I've only put single slashes. Now what happens is, the minute you write R before a file name, it says treat the string that is written after R as a raw string. Raw string, it means it does not consist of any escape sequences. So even if there was a tample file, it would be taken as slash and sample or slash and tample. It will not take any of these characters as escape sequences, because the R here says that all the content, the file name that I have written, the file name that I have written is just a raw string, and it has no special meaning attached to any character that you see in that file name. Clear? Okay, now let's go on to see what are the various opening modes that we can see. or access modes that we can see. You can write any of these access modes that we have seen here. Now we're talking about only text files as of now. In this video, we'll be only dealing with, in this and the next video, I said we'll be dealing only with text files. Okay. So if you're planning to open a file in the read mode, that means you want to get in the contents from the file into your program, then you're going to be making use of the access mode or file mode, which is going to be R. And I told you by default, it is R. Okay. So whether you write R or no, by default, it is going to be R. If you're planning to write something to the file, then it is W mode. But before that, let me just tell you some important things about read and write. Suppose in my previous example, I was trying to open a file named as sample.txt in read mode, correct? But what if sample.txt did not exist? Then in that scenario, it gives me an error saying that sample.txt does not exist. But if it exists, I'm talking about read mode, okay? But if it exists, it opens that file for me so that it's available for reading, okay? Now what happens when I say write mode? Again, when I say write mode, this file name that you specify could be existing or could not be existing. If it is existing, it will open the existing file. But what will happen is the contents of the file will be lost. That means it will open existing files, and if anything is there in the file, it's going to get deleted. But if it's not existing, let's say you try to open a file named as sample.txt and sample.txt file does not exist, then in that scenario, it creates a new file. Okay, so let me tell you the difference between R and W once again, okay, to reinforce. If you're opening sample.txt in read mode, it will only open if the file exists. Because if it doesn't exist, what is there to read from it? And it shows you an error message when the file doesn't exist. If you're planning to open a particular file in write mode, then the file may exist or may not exist. If it exists, remember what it does. It will delete all its old contents and give you a fresh file. If it doesn't exist, then it creates a new fresh file. Both the cases, it's fresh only, but one is creating a new one and it's fresh. One is opening the old ones, deleting the previous contents, and it looks like a fresh file. Is that clear? But there are times that I'm going to write something to a file and I don't want the previous contents to be touched. I want it to remain there and I want to continue writing. Then in that scenario, make use of the append mode. That's called A. When you say A, you basically mean to write. Okay, so when you open the file in append mode, it means if the file is existing, open that file, but don't delete its contents. You add on from the end of that particular file's data. Okay, but if it doesn't exist, obviously what will it do? Because it means write, it will open a new file. Okay, now what about R plus? R plus means you're planning to open a file in read as well as write mode. So at the same time, you can read as well as write. But remember, because you have written a R, if the file doesn't exist, it will give you an error. Because when you use the read mode also, it said if the file doesn't exist, it gives you an error. Now W plus also allows me to write and read. Then what is the difference between R plus and W plus? In W plus, it's all having all the features of the write mode, which means if the file exists, okay, if the file exists, it will delete its contents. Then you might think, then what will I read after that? After you write something into it, it will probably allow you to read. But at the opening, if the file exists, it will delete all its contents. But if the file doesn't exist, it doesn't give you an error like the R plus, but instead it creates a new file. So though R plus and W plus both allow you to read and write, R plus will have all the features that we were talking about when we spoke about the mode R. And W plus will have all the features that we spoke about when we spoke about W. Now what's A plus? A plus also allows me, the plus basically means allowing you both read and write, but it will have all the features of the A mode, which means if the file exists, it will open existing file, but it will not delete its contents. And you may write to that file or you may read from the file. And if the file doesn't exist, what does the append mode do normally? Creates a new file. Is that clear? So I hope the file opening line and the file modes are clear to you. Okay. Next, we shall learn how do you close a file. Very simple, not as complicated as open. Very simple. You just write the name of the file object dot close. We're going to be making use of a function named as close. Now, did you see here? We did not specify the file name. We just said fin.close. I told you the only time we would probably be specifying the file name is when we are going to open it. After that, whenever I use that file, I'm not going to be referring to the file with its name, but I'm going to be referring to the file with the object that was used to open that particular file. Okay. So if fin was used to open a file named as sample.txt, then what does fin.close mean? That you're closing the file sample.txt. So you're not closing fin basically, you're closing the file that was connected by fin. So fin is the connector for me in the program. Fin is the object that connects me to the file. So the minute you say close, that file gets closed. So fin continues to remain in my program because it's a variable of my program, but the file that it was connecting to is closed. Is that clear? So we learned how to open, we learned how to close. Let's learn how do I write something to a file. Okay, we're going to be learning two methods of writing to the file. One is using the write method and one is using the write lines method. What is the difference? We will see shortly. Okay, so let's learn how to write something to a text file. And remember, children, we are only talking about text files in this video. Okay, how do I write something to a file? Is by using a function named as write. Now, what is the way or what's the format of using the function named as write? You write the name of the object that connects you to that particular file, dot write, and in the bracket, you specify the string that you want to write to that file. The string could be directly a string literal like hello, or you could be reading the string from the user into a variable named as, let's say, str1 as shown here, and then writing the contents of str1. So you could directly write a string literal, or you could even write the value of a variable that the user has entered. Okay, to see some examples here, but remember one thing, before I write, what do you need to do is open the file. Yes. So let me just take you to one example. Here, I've opened a file named as example.txt, and can you see the mode as W? If you do not specify the mode as W, it will be taken as read mode. Okay, so now because I'm planning to write, I've opened the file in the write mode. And I told you for write, I'll be using fout. And for read, I'll be using fin, but they are not reserved words. They are just some object names. Next, I wrote fout.write hello there. So what is happening? This file is opened in the background, which is example.txt. And from my Python program, I'm transferring this data to that file called hello there. And finally, when I'm done with the file, I say fout.close. Now, I just want to tell you something about close. If I hadn't written close, and after executing these two lines, I don't leave Python. I simultaneously go and open example.txt to see whether anything was written. You might notice nothing is there. And you might wonder, is there anything wrong with the lines? No. You know how the write basically works? This is the variable that is having the data. This is your file. When you say write, whatever is supposed to be written is put in something called a buffer area. Buffer area is just like a collection area, you can say. So whatever you want to write, keep transferring it into the buffer area. And when the buffer becomes full, now we don't know the buffer size, but when the buffer becomes full, it pushes the contents of the buffer into the file. So now writing hello there is definitely not going to make the buffer full. And that is the reason when I opened that particular file, I saw nothing in it. But write did take place. So write transferred hello there into the buffer. Now the buffer is waiting to get full. Then only it will transfer it to the file. But I don't know when the buffer is going to be full. So what do? I write fout.close. What does close do? Apart from just closing the file, it will clear the buffer. So when it clears the buffer, what does it do? It forces the contents of the buffer to be pushed into the file, and the write operation can actually take place correctly and you can see the answer. Okay. Instead of using close, so close is not just, remember, closing the file, but it's also cleaning up the buffer area. That means whatever is in the buffer, it will force push it to the file and then close the file. Okay. Instead of the close function, you could also use a function named as flush. Flush also clears the buffer, but remember, it can't close the file. So close can do what flush does, but flush cannot do what close does. Close is clearing the buffer and closing the file. Flush is only going to be clearing the buffer. So if I had written this line and if I actually opened my file in Notepad, how would I see it? I would see it something like this. So I've just opened my file in Notepad and I see hello there. Is that clear? Let me show you another example. Okay. Now assume that, example file already contains some data. We just saw. Now what does it contain? Hello there. Now what do I do in the next example? I open the file once again in write mode. Okay. Is example.txt existing? Yes. But what did we learn? If example.txt exists, it will open the existing file and it's going to delete the contents. That means we are going to be losing the string hello there. Okay, and after that I said fout.write file handling in Python. So now if I ask you what's the content of the file, it's not hello there followed by file handling. Hello there, we deleted it or we lost it because we opened an existing file in write mode. And I'll show you what exactly happens. See, so we have no hello there anymore. It is just showing file handling in Python. Clear? Okay, let's look at another example. Here, I've opened the file in append mode. So what is currently there according to our previous example? File handling in Python, that word is there, okay? Now to that word, I'm writing, hope you are enjoying it. Now the question is, will it be on the same line? Will it be on a different line? It is going to be on a same line because you have not specified the new line character. So what happens is, when I see it, it is going to be on the same line. But what if I wanted it to be on another line? Then you can specify the new line character as I show in this example. So in this example, can you see I'm again opening example, but in append mode. What does append mode do? I said it will not erase the previous contents. It will just allow you to append or add contents to the existing file. And now I wrote /n, that means before this message goes into the file, go to the new line and usage of new line character should be added to this file. So how do you expect to see the file? You expect to see the file in this form, the first line and the second line attached together. After that, because of /n, usage of new line character came on the next line. Is that clear? So this is how your write function works. Then we have another function called writelines. Now what does writelines do? If you have a list or a tuple, okay, if you have a list or a tuple which has many strings in it, okay, so the first element of the list is a string. A string means it could be a character, it could be a word, it could be a sentence, whatever. So you have many strings in a list or many strings in a tuple, and you wish to write all these contents into the file. Then in that scenario, we can make use of the writelines function, okay? Whatever is in the list will get transferred to the file. So if I write this, see my list. My list consists of names Pooja, Rohan, Amit. But like I told you, this is just a word. Your list could contain one sentences or paragraphs or anything as individual elements. So when I say fout.writelines only once, the entire content gets written to the file. Now again, question is, will it be on the same line or the next line? Did you put a /n? No. So if you did not put a /n in the names, then why will it be on the next line? It's going to be like this. But suppose your list had Pooja /n, Rohan /n, Amit /n, then what would happen? After it writes Pooja, it would go to the next line, then writes Rohan, goes to the next line, then writes Amit, and then goes to the next line. Is that clear? So remember, going to the next line depends upon whether you have specified the /n character as a part of the string or no. Clear? Okay. Now we learn is how do you read the contents from a text file. For reading, I'm going to be showing you 3 methods. One is read, one is read line, and one is read lines. Okay, so let's start with the read method first. Okay, now if you look at the read function, it has n written in square bracket, which means n is just optional. You may specify n or you may just leave it empty. When you leave it empty, what does it mean? It's going to read the entire contents of the text file into the variable that you see on the left hand side. But if you write read with 5 or 10 or 15, it means that many bytes. Now each byte represents a character. So if you say read 10, it will read 10 bytes, that means 10 characters from the file, and store it into the variable called var. Is that clear? Okay, so just showing you an example, let's assume that your file contains this. Okay, so this is the contents of my file. Okay, and the name of my file is, let's say, sample.txt. Okay, so this is the contents of the file, and it's on 2 different lines. If I say fin is equal to open sample.txt, we know it's going to open the file. This, if you look at the read function, it has no parameters. That means what? Read the entire content. So welcome to file handling, full stop. Hope you are enjoying it, full stop. All this contents along with the /n character. It will not show you the /n character, but it has a /n character. That is the reason the next line has gone down. Okay, along with the /n character will be transferred to the variable called s. Then when I say print s, it will exactly show me what it is showing above. While displaying the string, it never shows us the /n character. It only does what the /n character is supposed to do, is go to the next line. Is that clear? But if I had written fin.read and in bracket 10, what does that mean? I need to read 10 characters. Now, from where does it read? You remember one thing, that there is something called a file pointer associated with files. And that tells you what to read, or from where to read, or from where to write. Whenever you open the file in read mode, the file pointer will always be at byte number 0, which means the byte which stores the first character of the string. And therefore, every time you read, as you open the file, it will be from byte number 0. But remember, after I finish reading 10 bytes, after I read 10 bytes, the record pointer is going to be moving to the next byte because you've already finished. So this record pointer, without you knowing, is going to keep moving in the file as you read or as you write. So when I say fin.read, what happens is, welcome to, this entire thing is 10 characters, is stored in a variable named as s, but my record pointer reaches this space. Okay, so it's located there because it read the first 10 bytes, and that first 10 bytes, if you say print s, so it will only display to you welcome to. Now what if I want to, now welcome to is only a part of the string. What if I want to, keep reading till I reach the end? The end part, that means beyond the last thing, is called the EOF, end of file. So what if I want to keep reading till the end? Then in that scenario, we could use read with a loop. Okay, and you need to remember one thing is, if the read function can read anything, even a dot, if the read function can read anything from the file, that means it has contents to read, it will return the contents that was read. But if it reaches the end of file, and if you still say a read in the loop, then it returns an empty string. So the variable s will get an empty string if there's nothing more to be read in the file. But if we have contents to read in the file, then s will definitely get those contents. So now how can I write the loop that will read till I don't reach the end of file? I can just probably show you a small example here. Okay, and let's say I'm reading 5 bytes at a time. So I write s is equal to fin.read 5. Okay, and then I write while s not equal to an empty string. Okay, now when will s become an empty string? If it couldn't read anything. Okay, if it couldn't read anything, this is an empty string. Okay, I'm just showing you a space there, but it's an empty string. If it couldn't read anything any further, it will get an empty string. So I am saying if it's not an empty string. If it's not an empty string, then what do? You process S. That means you do whatever you want to do with that string. And after that, you read once again. So you write S is equal to fin dot read and read the next 5 characters. And this will go on and on and on. And at one point of time, when the record pointer reaches the end of file and there is nothing else to be read, S will get an empty string. And when S gets an empty string, this particular loop will be closed. So now what do you mean by process S? That will depend from question to question. What are you supposed to be doing with S? Remember here, S is a string. So what can you do with S? All string manipulations that you have learned in class 11, like counting alphabets, digits, counting the thers, reversing a string, all that could be the processing part of S. Okay. So basically, you're supposed to be knowing all those string related questions. But you need to know that now the user is not going to be supplying the string to me. It will be read from the file. Is that clear? So is this read function clear? Okay. So then let's go to the next function. It's called the read line. Now what does this function do? That read function was reading either the entire file or the number of bytes that you specify. Here, it will read either one line at a time or the number of bytes that you have specified. When you specify the number of bytes, it behaves exactly like the read. Okay, like if I say 5, it'll read only 5 bytes. But when you say just read line without parameters, then it's different. Read without parameters, read the entire content, whether 10 lines or 100 lines, everything is read. But read line issued once will only read one line of your program. But what if it has many lines? Then use a loop like I showed you before. Even read line returns an empty string when it reaches the end of file. So you can keep reading as long as it doesn't return an empty string. Okay. So to see an example of this, I wrote S is equal to fin dot read line here. Just let me just annotate so it becomes easy. So I wrote this. So what does it mean? Read just one line. And what's the first line? Welcome to file handling. And it displays that. But like I said, if you write read line in bracket 10, it would display welcome to, same like the read. The only difference is read without parameters reads the entire file. Read line without parameters just reads one line. And same loop that I showed you before, you could use that loop because readLine function also returns an empty string if nothing can be read from it. Clear? Okay, so now let's go to the last function that we need to do under the reading part, and it's called the read lines. It is something similar to your write lines. What did the write lines do? Whatever is there in a list, many strings in a list was written at one time. Same thing. What does read lines function do? Whatever is there in the file, one line at a time, not one line at a time, all the lines it will pick up and it will put it into a list. So it's the reverse. The previous one was transferring from the list many strings into the file. What is read lines doing? It will read the entire file and each line it will transfer it as one element of the list. To understand that, again, my string is the same. I write the line, let me just annotate it. I write S is equal to fin dot read lines. Now S is not a string variable, it's a list. And what will it have? The first element of the list will have the first line in the file. The second element of the list is going to have the second line in the file, including the new line character. Can you see what's here? Okay, so it was the first, that means S of 0 is having the first line, S of 1 is having the second line. Now, you might ask, after reading this, how do I do processing? After reading this, now I don't need the file at all. Then I need to process it as though I'm processing a list. And how could I traverse through each and every element of the list? I could say for X in S. So what would X mean? The first string for the first time. Then when I come back to the loop, X would mean the second string and so on. So it would be just like traversing a list. Is that clear? So did you understand? For writing, we made use of two functions: write, writing a string; write lines, writing a tuple or a list of elements. But they have to be strings, okay? Because it's a text file. While reading, we said read, read line, or read lines. And read lines, I said, is opposite. The flow is opposite. If write was transferring list to the file, write lines, read lines is transferring from the file into the list. Is that clear? Okay, so in this chapter, I have just, this part of the video, I've only shown you all the methods of writing and reading. In the second part of the video, you will actually learn how to implement these methods in programs that are asked in the board exam and some of my general questions. Is that clear? So I hope this topic of text files, now we've only dealt with text files. I hope the concept of text files is clear to you. After the next video, which is about the programs of text files, I will start with the binary file. Is that clear? Okay, bye-bye. Thank you.